Hello, in this lesson, I'm going to do a probability review. That's chapter 5, 15253 of your textbook. I suggest you, before you watch this video, I suggest you try the probability review first. All right, let's start. So first, let's do some probability. One, find the following probability if you know that P of E equal to 0.118, P of F 0.42. Show how you get your answer in the with formula. Okay, so A asked me find P of E or F if P of E and F is equal to 0.25. Now the keyword is OR, and for OR probability, we should in here we tell us to add. So let's recall that P of E or F is equal to P of E plus P of F minus P of E and F. That's the general formula for OR. Okay, let's just plug it in. So I need to look for, I know the P of E already, so given to me. I also know P of F, and I also know P of E and F. So it's a direct plug-in type of problem. So let's do it. So I plug it in. I would have P of E or F is equal to P of E, in this case is 0.18, plus P of F, which is 0.42, minus P of E and F, which is 0.25. And simplify that, we get a 0.85. So P of E or F is 0.85. Right? B, P of E and F, if P of E or F is equal to 0.31. Okay, let's see the formula here. I know P of E or F. I know P of this one over here. I know P of E. I also know P of F. The only thing remaining I don't know in this equation here is just P of E and F. So what I have to do is substitution again. So let's do it. So P of E or F is 0.31. I'm using the same formula. Is equal to P of E, which is 0.18, plus P of F, which is 0.42, minus P of E and F, which is only unknown in this formula. Okay, so simplify with 0.31 is equal to 0.6, and then minus P of E and F. Now I can so I can just subtract 0.6 to both sides, divide both sides by -1. Then I would have P of E and F is equal to 0.29. Okay, and let's try C. So find P of E or F if E and F are disjoint. Again, disjoint meaning that there's no overlapping, there's mutually exclusive, another word for it. So if two events are disjoint, then I can say P of E and F is equal to 0 because they're disjoint. So P of E or F, I can just add using the same formula. So P of E or F is equal to P of E 0.18 plus P of F, which is 0.42, minus P of E and F, which in this case is 0 because they're disjoint. Right? So simplify that, P of E or F is equal to 0.6. Oh, this is 0.42, not 0.4. 0.42. Be careful there. So this will be 0.6. Okay, and let's do D. P of E and F and E of F are disjoint again. Two events are disjoint. I'm finding E and F. So again, disjoint tells me that what is the intersection? Disjoint again. Think about it. You have E, you have F here. You like E, F. I'm looking for E and F. That's not overlapping, mutually exclusive. So since they're disjoint, the joint probability must be 0. So therefore, I can say P of E and F is equal to 0. So if two events are disjoint, the N probability is 0. Let's do P of E complement. Now this notation here means complement. So we'll say complement event is equal to 1 minus P of E, and which is equal to 1 minus 0.18, and that gives us 0.82. Okay, last one, P of F complement. Again, complement is equal to 1 minus the probability P of F. That's equal to P of F is 0.42. So the answer for that one is 0.58. Notice that for this problem, the formula that I'm using is this one here. The only formula I'm using, right? I'm using this only one. And two things to remember, a key thing to remember is if disjoint, two events that disjoint, let me write it out, summary. So one, if E and F disjoint, then P of E and F is equal to 0, which is given by part D over here, right? If they're not disjoint, meaning the joint probability is not 0. So watch out for that one. All right, let's do number 2. Number 2 says a standard deck of cards contains 52 cards. One card is randomly selected from the deck. Find the following probability. Right answer is a fraction and simplest form and a 3 decimal significant figure. Okay, so let's do that one. So a deck has 52 cards and I'm randomly selecting 1. So selecting an ace or heart from the deck. Okay, let's think about it. Ace or, can notice keyword here, or tells me add them. So ace or heart. Well, ace is there are 4 cards that's the ace. So 4 out of 52, that's ace. Right? And then let me just write it out before I, so this is 4 of them. Heart, meaning that there are 13 cards that's a heart. Okay, but they do overlap. Think about it. Ace of heart, their ace of heart will be 1 card. 1 card that's ace of heart. So find the or, add the probability minus the overlapping. So I say P of ace or heart is equal to P of ace plus P of heart minus ace of heart. That's only one of them, ace and heart, which is the card that's ace of heart, ace and heart. Notice that you can write a formula down. So we say there's 4 ace, 8 of 52, that's ace, 4 aces, and there are 13 cards that's a heart. And then there's 1 card that is ace of heart. So when you subtract and simplify, we'll get 4 over 16 over 52. And when we reduce it, I will get 0.3. When I simplified it to decimal form, that's 0.30A. Okay, notice that the fraction is not in simplest form, so let me reduce it. Let me write 16 over 52 here, reduce it. So that reduces to 4 over 13. Okay, so that will be my final answers. Part B, selecting a 2 or a 5 or a 7 from a deck. Again, notice the keywords or here. Or tells me to add them, if then subtract the overlapping, the n, right? So I want, in selecting a 2, the 4 card that's a 2, a 5, the 4 card that's a 5, and then the 4 card that's a 7. Well, do I have a card that is a 2 and a 5 and a 7 at the same time? The guy's answer is no. So the events are here at disjoint. Disjoint meaning the probability n is 0. Probability of 2 and 5 and 7 is 0. So we'll have to just add them. Right? So we'll have 4 out of 52 plus 4 out of 52 plus 4 out of 52. And that gives me 3 times, so 12 over 52. That reduced to 3 over 13. And 13. And in decimal form is 0.231. I suggest you pause the video and try C and D yourself. Okay, so selecting a 4 and a black card from the standard deck. Again, in a standard deck of cards, there are 4 cards, there's a number 4, and a black card. Black card is half the deck, right? half the car is black, half the 52 car is red. So therefore, I would have a black and the black. So half of them is black here, total, which is 26 of them. 26 cars are black. Half. Now the question asks me the N. Selecting a 4 and a black car. Okay, another way of facing the problem is what is selecting for black car 4, right? 4, again, N. Again, think about the overlapping. Think about you have in 4 cars, you have 4 cars that's a 4 and black car that's 26, but 2 of the 4 here is black. So half the 4 car is black here. The overlapping of 4 and black is just 2 of them. So therefore the answer is 2 over 52. So reduce it will be 1 over 26. Within 3 decimal will be 0.03a. Not selecting a jack. Okay. Now notice the keyword for not is not here. Not tells me I'm looking for the complement. So not selecting a jack will equal to 1 minus selecting a jack. So probability of jack, how many jacks are there in the deck? Well, with the jack, we know that is 4 of them. So not a jack, but jack complement will equal to probability of not a jack will equal to 1 minus probability of jack. So that's equal to 1 minus 4 over 52. It's the same thing as 52 over 52 minus 4 over 52, which is 48 over 52. And reduced fraction gives me 12 over 13, or in a decimal form is 0.9231. Let's do another problem. Now this one is a two-way table, for probability. So this is quite a common type of problem here. So say in a national survey conducted by Center for Disease Control to determine college students' health risk behaviors, college students were asked, how often do you wear a seatbelt when driving a car? The frequency are given below in the table. So notice that those are responses. The first column, second column is frequency, and the third column is ask me to find probability, which is A. A says construct a probability model for seatbelts used by a driver. Now, probability model meaning that given all possible outcome or probability listed out in here, I know that if I add up all the possible outcomes, the probability column here should be 1, and call that one 3 significant digits. So we say probability is equal to is same thing as the relative frequency, I think, in way of calculating. Think about relative frequency. Relative frequency, right? The way of calculating. So which is the frequency over the total. So the total here, if we add them all here, you get a total of 4,370. Let me write total. Okay, so let's find the probability. The first one will get 120 over the total, 4376, and 3 decimal place. That gives me 0.027. I can do the same thing for each one of them, so let me just write it. So next one, you calculate it, you get 0.040. Next one is 0.079, and 0.162, 0.692. Again, you can check your work by add up the probability here. That should add up to close to 1 or 6-1 here, not 2. All right, be careful there. All right, so this is the probability distribution. Part B, what is the probability that a college student will rarely or never wear a seatbelt? Again, notice that the or is using here, never, rarely or never. Write your answer in a sentence and explain what outcome mean in this long run. Okay, so rarely or never. Again, notice that rare, never, that disjoint events. So a randomly selected person could be rarely or could be never wear a seatbelt, but not both, right? So they're disjoint. So to find the probability, we'll have to do just add them. So probability of rarely or never is a total, adding the two total together, which is 0.027 plus 0.040. Let me add them here. So this is 0.027 plus 0.040. and that gives me 0.067. Now the question asks me explain your answer in a sentence. Okay, let's think. So I can say the probability that I randomly select student will be rarely or never wear seatbelt is 0.067. In other words, I can say if I would randomly select 1,000 students, I can expect to see 67 of those students will be rarely or never wear seatbelt. Okay, let's write that. Okay, now notice that the reason I get out 1,000 because if I would multiply 0.607 to 1,000, I will get 67. So therefore, I interpret that using times 1,000. So 0.067. Let me write it out. Note that I have, if I'm using 0.067 times 1,000, that's equal to 67, right? That's kind of like calculating sample size 1,000, 67. Then I'm going to say that will be rarely or never wear seatbelt. Okay, that's part B. Okay, let's do C. Is it unusual for a college student to rarely or never wear seatbelt when driving a car? Let's explain that. So we say in general speaking, we say what is considered unusual is the event if its probability is under 5%. So in this case here, our probability of rarely or never is 0.067. That is more than 5%. So therefore, it's not considered unusual. So that's right. So this is not considered unusual. And again, so when considering whether it's usual or not, we need to think of in terms of the content or the application problem. Let's look at number 4. Number 4 says among 21 to 25 years old, 12% say they have driven while under the influence of alcohol. Suppose that 4 of 21 to 25 years old are randomly selected. So note that I'm going to select 4, so sample size is 4. I'm going to select 4 students. I'm going to ask whether they have driven under the influence of alcohol or not. So let's define the event. So let's say let a letter, I'm going to denote my letter. So let's let A, the event A, represent the age group of people, 21 to 25 years old, say that they have driven while under influence of alcohol. Okay, so it's important that you denote, kind of use notation to represent what we're trying to find here. It will make it easier to rewrite the problem or understand the problem. So if I let A represent 21 to 25 years old who said that they have driven while under the influence of alcohol, then P of A is equal to 12%, which is 0.12. Okay, so let's look at problem A. What is the probability that all 4 have driven while under the influence of alcohol? So let's think about this. So if I randomly select one of them, that student say, I have driven under the influence of alcohol. The second student say the same thing, third student, and the fourth student. So it's an N involved N here. So my goal is to find the probability of first one says driven under the influence of alcohol. The second student also say have driven while under the influence of alcohol. The third person also say have driven under the influence of alcohol. And the fourth one also say have driven under the influence of alcohol. So this notation here means A and A and A and A 4 times here. Okay, let's think about the events. Are they independent or not? Think about it. Whether the first person say they had driven under the influence of alcohol or not, does not change whether the second person will have driven under the influence of alcohol or not. So therefore, the events are independent. Since the events are independent, I can use independent rule to find N. Well, independent rule for N is multiplication. So let's recall it for N. We say, I'll learn that the probability review, we say if A and B are independent, if A and B are independent events, right, then P of A and B is equal, same thing of P A B here, if we want to rewrite it, is equal to P of A times P of B, Right? That's the probability rule here. So let's use that to do our problem. Okay, so I'm going to find probability of A times P of A times P of A times P of A, since the events are independent. Okay, that means that P of A is 0.12. So 0.12 times 0.12 times 0.12, 4 times. Same thing as raise that to the full power. Right? So that is equal to a very small number. I think in your calculator, let me write in the scientific notation from your calculator, you will see 2.08 times 10 to the negative 4 power. Well, negative 4 power here doesn't mean that the answer is negative. It means that this is a very small number. You can convert that to a standard form by move the decimal to the left 4 times. So we have 0.1230208. That will be the probability in standard form. Okay, negative 4 here doesn't mean that it's a negative probability. You will never have negative probability. So it's a very small number. Okay. Well, we could explain that under in one sentence. I say the probability that all 4 have driven while under the influence of alcohol is 0.00208. Or in other words, what that means is, know that if I would multiply the whole thing, let me try here, to 10,000, let me write. So what that means, if I would randomly select 10,000 people, sample 10,000 people, I can expect that 2 of them will say that they have driven while under the influence of alcohol. Right? That's what it means here. Again, notice that I multiply 10,000 here and approximate the 0.000208 to 0.002. I can also say 100,000. If I do 100,000, then I will have approximately 21 of them gonna say that they have driven under the influence of alcohol. So using the multiplication rule kind of help me to find the probability. Then I interpret that by writing in a sentence involving 10,002. And let me say that again. I'm not going to write it. So say if I would the probability that all 4 have driven while under influence of alcohol is 0.000208. That means if I would randomly select 10,000 people of age 21 to 25 years old, I can expect to see 2 of them will have driven under influence of alcohol. Part B, would it be unusual for all 4 to have driven while under influence of alcohol? Okay, think about unusual. We say unusual if events are under 5%. And in this case of 5%, it should be good to use here, because notice that 5% in decimal form is 0.05. This number here is definitely less than 5%. So therefore, yes, it is unusual to see all 4 have driven while under the influence of alcohol. Again, 10,000 out of 10,000, approximately 2 of them are going to say that have driven while under the influence of alcohol is pretty low. Okay, so let's write that. Okay, so since again we're using the rule of under 5% to determine whether it's unusual or not. So since we say it's under 5%, we say is considered unusual. Again, don't drink and drive here. I think the probability of randomly selected person have driven under alcohol is 0.12 here. Hopefully you're not one of them. All right. Thank you for watching the video. I'll see you next time.